Welcome to our live demo for flexible manufacturing series on the lighting industry. Thank you for tuning in and joining. At SNIC Solutions, our mission is really to help our customers create flexible manufacturing environments, and we do so by bringing our solutions to help improve operations and supply chain. I think when we talk about what is flexible manufacturing, what our solutions do and how they help benefit their customers, there's a lot of different terminology that gets used in the various industries and various customers. So what we wanted to do is describe what flexible manufacturing means to us. So no matter what kind of project we're doing or what kind of sort of manufacturing operations, digital transformation project we're on, there's really one common theme. There's a lot of different metrics, a lot of different KPIs that are looking to be attained or improved upon. But at the end of the day, there's one thing, and they all roll up to having a more flexible business model when it comes to their manufacturing. Maybe they want to grow their top line by adding new products. And while we're familiar with speed to market and new product introduction, what we don't talk a lot about is how your operations and how your production floor needs to be prepared and ready to take on new products. If we want to increase throughput, maybe we just want to reduce our cost of goods sold, improve our efficiencies, or ultimately improve the bottom line. How do we do that? What metrics go into it, and how do we improve upon those metrics? And we do so by having a flexible business model and also the visibility and decision support tools to create that. So today we've asked our specialist Tulio Rocio to help us and show us some of those use cases.
Thank you all for joining us today. We will be covering a range of key features and benefits of APS in the lighting industry. APS stands for Advanced Planning Scheduling. So this topic is of great significance because efficient production scheduling is crucial for maximizing productivity, meeting customer demands, and maintaining a competitive edge in the industry. We will explore automatic scheduling, which eliminates the manual efforts and time-consuming nature of traditional scheduling methods, usually based in Excel spreadsheet. We will also delve into the concept of create scenarios, allowing you to simulate and compare different production schedules to find the optimal solution for your business. In addition, we will discuss the importance of material planning ahead of time, ensuring that you have necessary resources and components available when they are needed, minimizing delays and bottlenecks in your production process. We will also show traceability as a significant focus here. APS provides visibility into the entire production workflow, enabling you to trace and track each step from work order creation to completion. First thing I'm going to show you is the Gantt chart here. On the left side, we have the resource that will have work orders on the workload here. So we have component assembly, machine 1, machine 2, and down here we have final assembly. So on the top we have the timeline, and we also have diamonds here that shows us the purchased orders. So we have 5 future purchased orders for components and materials, and we also this diamond here before this red line. The red line means the actual time. So this diamond before the red line means our available stock, right? So this is our available stock here. In the middle we see the white space here means on shift, and the hatched means off shift or maybe planned maintenance, and we can set different calendars for different machines, right? On the bottom here on the Gantt chart, we see also some diamonds, which represents the your customers' orders, or maybe work orders to supply for finished goods stock, right? So down here we have the second panel, which shows us the usage of every resource we have up here in the Gantt chart. So as we can see, we have for the first day here we are scheduling, we have 25% of unavailability for machine 1 and 75% of availability for machine 1. So we have for final assembly 100% availability, which means 24/7 workload, right? So on the very left side here we have all the work orders that we will need to schedule. Let's have some scheduled scenarios here. So first I will have a manual scheduling process, which basically means I will drag and drop the work orders, and as you can see, the OpCenter APS does not allow me to load this work order on a different machine. So based on the ERP, we have the machine that is able to produce this work order. So automatically when we place the work order on machine 1, we see down here that we have now 14% of utilization for machine 1. So let's have the second work order for component assembly here. 57% of utilization with this work order. So, but scheduling manually is it's too hard when you have so many work orders, and this is not what you are going to do having a scheduling tool, right? So then we're going to have automatic scheduling, and we will try basically forward sequencing by due date. So which means OpCenter scheduling will schedule first the work order that has the first due date. When we do that, we see all the work orders placing on the Gantt chart, which also gives the workload of the machines on the second panel. And we can see also the usage of head counts, operator with skill A, operators with skill B, operators for assembly. So we have then the information of some constraints that we may have in the lighting industry, right? So with this scenario here we created, we can see some the first use case I want to show you here is the traceability, and how you can trace and track the future of your work orders, right? So let's have a look at this work order here, A203. So this is our work order, quantity 25, due date January 13th. And what are the work orders that are related with this final work order here, that is a work order for SQ03. So we can highlight the previous operations. So then we can see that work order 203 is linked to work order 103, work order 003, and work order 105. So we can see this previous operations, and we could also see all previous operations. So then we have here all previous operations related, which means that we can find some opportunities to improve our scheduling here. So what are the opportunities we have here? So first, I wanna show you here that we have a red line on the top of the A203 work order. That means that this work order is going to be delayed, right? So we can see here there is a red line, and I am not finishing my work order by or before actually my due date. So this red line shows me that I'm going to be delayed. Different for A202. So A202 is going to be on time. We can see that here on the Gantt chart, right? So what's causing me this delay? That's the question that you may find the answer and may solve the problem to not be delayed. So as we can see, when we highlight all previous operations, so we see that we have some relation here with purchased orders. So the work order A003 is going to start on the 13th because some material will arrive by this day. So what if we could actually start earlier this work order? Let's assume that the scheduler called the purchase team and asked to call the supplier to bring the material earlier. So the purchase team said that the supplier agreed and they're going to bring it earlier. So then we can drag and drop the operations here, right? So we can drag and drop the operations and check if we could have it on time. As we can see here, now we have the work order 203 on time. So this is a scenario we create to interact with the purchase team and have them help on this scheduling situation we just found here, right? So I will save this scenario. I will save this scenario here. So you can save as many scenarios as you want. Oops. Scenario 1. Right. So if you have any questions, please write those questions on the comments. Right. I want to show you the impact we have on the head counts. So when we do this scenario, we have to be able to see all the impacts we have in other constraints, right? And that's a problem that schedulers usually face when they schedule using spreadsheets. They are not able to see what happens in other areas as headcounts or maybe purchased orders, etc. So let's have a look here in the plot window. So we see that we have different constraints here. I will open a little bit more here. So yeah. So we have a constraint of power usage, which is going to be higher than the planned quantity here. So we can see by this red piece here. So assembly operator, it's going to be fine. So we are not going to need more than one assembly operator, but operator with the skill A that we have only 2 available, we might need one more, and so we have to take that in consideration. And operator skill B that we have 2 available, we only need 1. So in this case, the scheduler could call the supervisor and ask them to have one of the operator with skill B working for operations that requires skill A. If that works, we may have this scenario approved, but maybe this is not allowed, or maybe this operator with skill B does not have the second operator here, because we have 2 availables. So the second operator here may not have the skill A, so this may not be feasible. So then we have to unschedule and schedule that again, saying, OpCenter, please consider that I have actually those constraints, and I have to take that in consideration. So we're going to sequence again using the same scheduling rule, and so now we have all the secondary constraints inside the limits, right? And what if I try to move this A003 work orders? So far so good. So far so good. When I move here, it's also good. So we still can have the same scenario we were trying to have before we were not considering the secondary constraint. And we could also move this one here, and this one here, and this one here. So I will now save this scenario, because actually this is the scenario allowed. So the supervisor said we cannot actually use the operator skill B in the operations skill A. So let's save the scenario here. So the next use case I want to show you is material planning. So OpCenter has the bill of material of each SKU, each product. So we are able here to see all the material needs we have for each operations, for each work order, right? So we have here some reports, and The first report I will show before showing the material planning is the list of operations we are going to have by each resource we just scheduled. So we have here a list of operations for component assembly. So as we can see here in the Gantt chart, here we have the sequence 002, 003, and 105. So it's exactly what we have here, 002, 003, and 105. But do not forget that the scenario we are going to release to the factory is the scenario 2, right? So still we have 002, 003, and 105. And we have here some informations, and we could also have more informations here. And we have, besides the sequence, we have the start time and the end time that the operator has to accomplish, and the supervisor also will manage this, right? So I will do some material shortage here. Let's change this to 200. And see if we have, yeah. So what just happened here is that if I change the quantity because of any reason, so then I automatically see here that I will need more 35 of those components here and 840 for the other component, right? And we can see if we click here, we can see which work order are requiring this quantity, right? This calculation is made by the bill of material we have on OpenCenter APS. And I know you guys will ask that, but we bring those informations from your ERP using automatic integration. That could be by CSV file, that could be web service, could be also database. Beside those two reports I showed you, we have so many other reports here that you can explore. We could also customize new reports here. So OpenCenter APS is open to create new reports. Thank you all for joining us today on how APS makes the production scheduling easy and flexible in the lighting industry. I hope you found this informative and valuable in understanding the benefits of advanced planning, advanced scheduling for lighting industry. So as we conclude here, I encourage you to take the knowledge you have gained today and apply it to your own manufacturing process, right? It's important to remember, guys, that implementing APS is not just an one-time effort, but that's an ongoing journey of continuous improvement, right? So it's many people ask us if OpenCenter APS is a plug-and-play software. No, it's not a plug-and-play software. The same as ERP. ERP is not an plug-and-play software, so the same happens for APS. So we have to implement, we have to model, and we have to be continues improving the solution we have for you guys. And so, stay informed about the latest advances in APS technology, collaborate with the industry experts, and consistently evaluate and refine your scheduling strategies, right? Thank you once again for your participation. We appreciate your time and look forward to seeing you succeed in your production scheduling endeavors. So, should you have any further questions or require additional resource, please don't hesitate to reach out to our team